three unknowns, in theory, it could be solvable as long as they're independent. If I can multiply any of these equations by some constant to get the other one, or if I can add two of them to get the third one, they're not independent, and it's not solvable. If you plugged it into your calculator, you should get an error. So first, we have to get rid of one of the variables. Instead of doing by substitution, I'm going to do solving simultaneous equations. So I'm first going to take these two equations here. I have to decide what am I going to get rid of. Since this doesn't have an a in it, I'm going to get rid of the a's here. So I'm going to multiply this top equation by 3. So I have 3a minus 3b minus 3c equals 0. The second equation I'll just keep as is, minus 3a minus 4b equals negative 8. And then I just add the equations. If I add the left-hand sides, I get a's drop out, and I'm left with negative 7b minus 3c equals negative 8. I now have that other equation down there, the third equation, and I'm just going to rewrite it. 4b minus 6c equals 12. It's looking like c is going to be the easiest one to get rid of. So what I'm going to do is I can multiply the top one by negative 2, or multiply the bottom one by negative 1/2. In this case, I'm going to multiply the bottom one by negative 1/2. So I have negative 7b minus 3c equals negative 8. And the bottom one, negative 2b plus 3c equals negative 6. And I add.
Now, how are you just able to like multiply it by negative 1/2 and then 3 on the top?
If what I'm doing is I have that's equal to this. As long as I multiply the left hand by something, I can multiply the right hand by something, it's still equal.
Okay.
Unless, of course, the usual method will apply to this. I want to get positive 3c down here, and I know multiplying so that these will cancel out when I add them.
Okay.
So I know if I multiply by negative 1/2, they'll cancel out.
So you're just trying to like cancel out letters?
Yep, absolutely. Now this works out nicely that I only have to multiply one equation at a time. There are times in which, if I want to get rid of b's here, I would probably multiply the top one by 4 and the bottom one by 7, so that I'd get negative 28, positive 28, and then cancel out.
So, answer it.
Okay. And we get the same thing as we got before, which is comforting.
So with those equations, we just combined the ones we had over here to get those, and we just changed them and set them equal to each other to find our answer.
I set two coefficients to be additive inverses so that when I add them, that variable drops out. Yeah. To get C, well, I got a mess of equations I can use. I could use this one, I could use that one. I could use actually any of the equations I have written down here. I'm going to go ahead and use this one. This seems like the simplest of the ones that I have. It may not be, it just feels that way. So if I plug this into here, I get negative 2 times that, so I have negative 28/9 plus 3c equals 6. 3c equals 6 plus 28/9. So that's 54 plus 28. Oh, that's negative 6. Thought something was off. All right, so negative, which is negative 54 plus 28 over 9. 26, negative 26 over 9. Oh, is equal to 3c. Therefore, c equals negative 26 over 27, which strikes me to be somewhere around negative 0.9629. It feels right. And if it's not, then we've made an error somewhere.
Yeah, that's right.
Okay. Amazing how I did that in my head. And then to solve for A, I probably use the first equation over there, because A is B plus C. So if I just add those together, add that and add this and this together, I think I'm gonna get somewhere around 0.5925 or so. I feel like I'm off probably about 4/10,000ths, but. And then there's substitution. We went through a substitution problem the other day when we did the problem that I set up the problem more complicated than I meant to. Questions?
So all of this was just to find how many amps, or how much current was going over some resistor.
Yes, absolutely. And this process here, that problem that we did the other day with the 1 battery and the 7 resistors, 6 resistors, whatever it was. You can use this to solve that also, and some students do. We have different technique. If we can reduce the resistance down to a single resistor, I should say some people find that simpler, just to reduce it and then work your way back, as opposed to doing this. All right, mesh analysis. We're going to solve the exact same problem, so I think you know what the answers are going to be. But we're going to do a completely different technique. Well, completely different. We just have 2 unknowns. Now, the reason why I'm going through all this again is that there will be, in class this size, I suspect, we will not have a monolith and everybody's going to do these exact same technique. Some people find one technique easier than the others. And as always, it's the way your mind is working at the time you need to do it. Now, the techniques I'm using to solve it mathematically, I don't care which technique you use. Try not to confuse them. And you could do multiple ones. Typically, I will use determinants to find the first one, and then I'll use substitution for the second one, and maybe the third one, system equations. It just depends on my mood. All right, mesh analysis. Instead of having the 1 current per path, we have 1 current per loop. And I have 3 different loops here, but I only need to choose 2 of them. I've got 2 loops here, and I'm just going to do left and right. And I am going to, doesn't matter, clockwise, counterclockwise, just pick one. I typically go clockwise. I'm going to call that current A, and this one B. Now, it looks identically the same. The tricky one is the middle. But, all right, now I'm going to do, I have 2 unknowns, so I need 2 equations. I don't have the junction rule. Well, the junction rule will tell us nothing. The junction rule will tell us that A plus B equals A plus B. But what I'm gonna do is I'm gonna do two voltage loops, and I'm gonna start somewhere and just pick it. So I'm gonna start there, and I am going to go around the left loop. So I have 3 minus 1A minus 4A plus 4B minus 2A equals 0. That's the tricky part right there, is the fact that I have two currents going across the middle. A, and my loop is going, I'm going a clockwise loop here, I'm going in the direction of A, so that's why the A1 is negative, but I'm going against the direction of B, so that's why that's positive.
How do we choose the points that we started at? Like the blue dot, can you just?
I typically start just before battery, just again, I like my first value to be positive, but that's just a me thing.
So if you want the first value to be positive, you should put it at the very start of the negative end.
And I could have started it here and gone this way.
Okay.
Should we put a +5?
There should be a +5 in there, thank you. Just realized that as you were saying, just before you spoke it. That sounded pathetic. Thank you.
So if you were to put the dot on the other side, on the positive, you would probably have to switch the rotations of the cycles we chose.
The rotations of the what?
The currents.
No, you don't have to switch the currents at all.
Okay.
It's arbitrary which direction you pick these, it's arbitrary where you start, it's arbitrary which direction you go in. Once you establish your currents though, you've now established, like establishing I hat and J hat, you've now established the convention that you're planning to use for the rest of the problem.
Okay.
All right. One equation, two unknowns. Let's do another equation. We can start anywhere. All I know is I can't do the left loop, I've already done that. I have the right loop and I have the entire loop. But I'm gonna start here, again, jumping stars. And I'm gonna go counterclockwise. So I'm gonna go this way with my voltage loop. So 7. I'm going to cross the 6, but opposite the direction of B, so plus 6B. Cruising on, coming down this one right here, I'm going to the direction of A, opposite the direction of B, so minus 4A plus 4B plus 5 equals 0. So physics gets us to there, then we do a bunch of math, and then physics pops in as we interpret what we get.
And then we get the same answer
We should, and if not, there's a mistake somewhere.
in the other two problems.
All right, so first let's simplify it. Let's see, I've got an A term, an A term, and an A term, so I got negative 7A. I've got 3 and 5, so I have 8 minus 7A plus 4B equals 0. And here I've got the 5 and the 7, so I got 12 minus 4A plus 10B equals 0. And then pick a math technique. Let's do determinants. Why not? So I have 8 is equal to 7A minus 4B. 12 equals 4A minus 10B. My denominator, 7, 4, negative 4, negative 10. And my numerator, 8, 12, negative 4, negative 10. feels like it should be somewhere around 0.592 something. So I get negative 80 minus negative 48 over negative 70 minus negative 16. Which is negative 32 over negative 54. Which I believe is what we had before. So 7, 4, 8, 12. 7 times 12, 90. 84, thank you. 84 minus 32 over negative 54. Which is 52 over negative 54. Which is negative 52 54ths amperes. Yeah, those A's are not the same. That A and that A are not the same.
As in they're wrong? Or?
No, that's amperes and that's the
The
current
left.
in the left loop. Now notice we have our value for B here, that's a 2. Our value for B here is the value of C we had before. Remember that the current flowing across the 4 ohm resistor here is a combination of A and B. So what I have here is across the 4 ohm, I have 32 54ths going down. And across B, 52 54ths negative going up. And I need to combine them. So what I'm going to do is I'm going to take my negative here and I'm going to flip the arrow and change it to positive. So I've got my 32 54ths going down. I have 52 54ths going down. They're in the same direction, it's just simple enough to add them. And I get 84 54ths going down.
Which is our C value.
Which was our B value before.
Oh, whatever.
It's the difference added together.
Say that again?
So it's just the two charges going opposite directions together.
We have the two currents that we initially established to be in opposite directions. And then because we mathematically got a negative here, we can flip the arrow and make it positive.
Okay.
I do want to point out that even though plus and minus make a difference, these are not vectors. These are scalars. The main reason why it's a scalar, not a vector, is I have current flowing in this way, I have current flowing this way, and current flowing that way. Yeah. If they were vectors, this would not work, because if those would cancel each other out, this one would have to be canceled out by something going up, but there's nothing going up there. So it's not a vector, so we don't have to worry about the direction as explicitly.
Will there be times where we will have to?
No, not for current. Just like time itself. There's negative time has a meaning, it happened before time is equal to 0, but it's not a vector. Yet. Yeah, well, within the context of this class, it won't ever be. Questions?
What do you think is the quickest way of doing it? Like, what do you do usually?
I usually do the 3 equations, 3 unknowns, but if I had thought about it logically, I would figure this one's a little bit simpler because I'm only dealing with 2 unknowns. As long as you can deal with the overlap,
for all the problems involving this, we're probably only gonna have 2 loops if we use this mesh analysis.
Yep. Wait, what was yes, it's mesh analysis. What was the question?
Will we only have 2 loops usually? Or
Yeah, yeah. On a problem like this, on the last problem on the next desk, it will, other than batteries might be flipped upside down, the numbers will be different. That's the basic setup right there. And on the quiz for chapter 21, that's the setup right there, other than batteries might be flipped.
So we can pick any of those 3 methods?
Well, there's 2 physics methods and oodles of math methods. Yeah, pick. My recommendation, pick a method for the physics, pick a method for the math. Understand it, do it, learn it. Try not to memorize it, that would be torture. All right, so what we're gonna do here, I have one here with the answers. I'm gonna put it up on the board. The answers are not integers, by the way. And you are going to work it and dazzle them with your brilliance. Problem I would like you to do. Make sure I've got the batteries pointing in the right direction, up, up, down, going from right to left. And then this is 8 volts. 6 volts, 4 volts, 3 ohms, 5 ohms, 9 ohms, and 7 ohms. What is the current? And in what direction? What is the current across each resistor and in what direction? And what is the voltage across the 9 ohm resistor? So we've got